Welcome to Physics Combined Science Paper 1, Higher. We're going to be going through all of the questions. Pay attention to some of the tips and tricks that I will give you. Figure 1 shows an electric whisk that plugs into the mains electricity supply. The whisk can mix food by spinning a beater. Give two energy stores that increase when the whisk is switched on. So when switched on, the beater spins. This movement increases the kinetic energy of the whisk. The machine or the food that absorbs the kinetic energy will increase in its internal energy. You could also say thermal energy. Maybe the whisk heats up. These both increase. Use the physics equation sheet to answer the questions 1.2 and 1.3. Work is done by the whisk when it is used to mix food. Write down the equation that links power, time, and work done. Power is work done over time taken. Remember, work done is energy transferred, so power is also energy transferred over time. The power output of the whisk is 92 watts. Calculate the time for the whisk to do 23,000 joules of work. We always start off by extracting the data from the question. In this case, we can just underline them. This is power, and this is work done. Power is equal to work done over time. Therefore, 92 is equal to 23,000 divided by time taken. We rearrange this equation to make time the subject. Time is equal to 23,000 divided by 92, which gives us an answer of 250 seconds. Here we're asked to pick out an equation from the physics equation sheet linking power, resistance and current. The equation is P equals I squared R. The current in the whisk is 500 milliamps. The resistance of the whisk is 640 ohms, and we are asked to calculate the power. Just really quickly, the first thing to do is pick out some of the values that we've been given. This is current. However, the standard unit for current is amps. So I need to convert from milliamps to amps. There is 1000 milliamps in 1 amp. So to go from milliamps to amps, I have to divide by 1000. The answer will become current is equal to 0.5 amps. Then we plug all of this data into our formula, which is P is equal to I squared, which is 0.5 squared, times by R, which is 640, which gives me the answer of 160, and the units is watts, which has already been given. These next questions guide us through very simply. It asks what the potential difference between the live wire and the neutral wire in the mains electricity supply is. This is 230 volts. Changing the beta speed does not change the potential difference between the live wire and the neutral wire. The power input to the whisk changes because the current in the whisk changes, and asks us to complete the sentence. When the beta speed increases, the current in the whisk increases because the resistance of the whisk decreases. Next. this question is about Rutherford's alpha scattering experiment. 2.1. What does the alpha particle consist of? The alpha particle is also called the helium nucleus. Therefore, it consists of 2 protons and 2 neutrons. 2 protons and 2 neutrons. Of course, drawing a picture doesn't get you the marks. You have to say 2 protons and 2 neutrons. The gold atom has a symbol given here. How many neutrons are there in this gold atom? In school, you'll have done PEN, protons, electrons, and neutrons. The proton number is that number, also known as the atomic number. To find the number of neutrons, you have to do the relative atomic mass, which is 197, take away the atomic number, which is 79, to get you an answer of 118. Make sure you write your correct answer on the answer line. The alpha particle scattering experiment led to the plum-pudding model of the atom being replaced by the nuclear model. The picture shows the expected result and the actual result from the alpha scattering experiment. If the plum-pudding model was correct, then what happened in the alpha scattering experiment disproved the plum-pudding model and led to the creation of the nuclear model. This question asks you to describe the results of the experiment and talk about the plum-pudding model and the nuclear model. You have to describe both types of models and what happened in the experiment. So it's a massive 6-marker. It's not judged on the complexity of your answer. Instead, in this question, it's judged on how much information you can include. So we start off by describing the plum-pudding model. We described J.J. Thomson's plum-pudding model as being a ball of positive charge with negative electrons embedded. Then, what did Rutherford's alpha scattering experiment show? First thing that it did was, most particles were undeflected, showing atom is mostly empty space. Number 2, some deflected, showing that center is positive. Number 3, very few, bounced back, showing center is dense. So, why did the plum-pudding model get replaced? All 3 of these things were not explained by the plum-pudding model. Okay, so none of those things were explained by the plum-pudding model. Then, what does the nuclear model now look like? Positive charge in the middle, and it's small. Atom is mostly empty space, and electrons orbit the nucleus. We don't know that they orbit in shells yet, but we do know that they are somewhere orbiting the nucleus. So, the nuclear model has mass concentrated in the middle and with a charge, electrons orbit, and mostly atom is mostly empty. Pay close attention to what I've said. Some of it I couldn't write down onto this little page. The scientists found the existence of neutrons after a while, and the person responsible for that discovery is James Chadwick. So now we're on to electricity. In this question, it asks you to complete the circuit diagram with an ammeter and a voltmeter. Ammeters are always placed in series with components, therefore the ammeter can be placed anywhere on the loop. I'm just going to place it right here. The ammeter has the symbol A. The voltmeter has to be placed across the component that you're measuring. In this case, the component that you're measuring is an LED, and the LED is here, so I'm going to place my voltmeter right here. This question asks, how would the student adjust their circuit to vary the potential difference across it from a range of 2.6 volts to minus 2.6 volts? Think back to when we did the IV characteristics. How did we change the potential difference or the current through a component? We did this by adjusting a variable resistor. This circuit does have a variable resistor, so you could use that. You could adjust variable resistor. The other answer you could have put is change the number of cells in the circuit, in the battery. But even that doesn't give you the negative values. To get the negative values, you have to reverse the connections to the battery, or reverse the connections to the diode, the component that you're measuring. You can't do both, you have to do one or the other. This question is a skills question. There is a table of results shown of the potential difference and the current in milliamps when the student conducted their test. You are asked to plot the graph. Notice some of them are done for you, so you only have to do the last four. Once you do that, you plot the line of best fit. So you draw the line of best fit. 0 is done for you. 1 is done for you. 1.8 is done for you. For the potential difference of 2, the current in milliamps is 5. On the left hand side, on the y-axis, it goes up in tens for every big square. So somewhere between 0 and 10 is 5. I've got to be careful that I plot it correctly. For 2.2, it's 19. It goes from 2 to 2.5 in 10 squares. So each tiny square is 0.5. 2.1 is here. 2.2 is therefore here. We work all the way up to 2.4, get to 19, and we place our X right there. Next, 2.4, all the way up to 41. 41. Then 2.5, 2.6, all the way up to 69. The line of best fit should look like this. Now, this is tricky stuff to do. Obviously, I struggled because I was working with one of these pens. You should be able to get right close with a sharp pencil and put X's that are no more than half a square away from their accurate place. Explain what happens to the current in the LED when the potential difference across the LED is negative. When the potential difference across the LED is negative, the current is 0. Why? Because the LED, the D actually stands for diode. And in a diode, there is very high resistance in the negative direction. 3.5. A student did the investigation using a blue LED. The results for both the red and the blue showed the same pattern. What conclusion can be made from this investigation? If somebody else can reproduce the results that you got in a different condition, that means your results, your investigation is reproducible. This question is asking us which IV graph shows a straight line, linear relationship. Lamps show a curved shape. This is the IV graph for a filament lamp. LDRs and thermistors vary the resistance, therefore is nonlinear. The resistor that is at constant temperature follows Ohm's law and shows a linear relationship. A drone is a miniature aircraft that has a remote control. An inventor designed a battery-powered drone. The inventor tested what would happen if the battery runs out of charge during the flight. Figure 5 shows the inventor about to launch the drone. After the drone was launched, it moved at a constant speed and gained height. Describe two other changes to the energy stores of the drone as it moved at constant speed. When the battery is used up as it's moving, the chemical energy store of the battery decreases. So chemical energy store of battery decreases. When the drone gains height, the gravitational potential energy of the drone increases. Why does the kinetic energy not change? Because it's moving at constant speed. When the drone was at a height of 840 meters above the ground, the motor was switched off. So here's our little person flying the drone, and here is the drone at a height above the ground. This whole distance is 840 meters. It's saying the motor was switched on after a short time after the drone had fallen. Maybe the drone ended up here. The change in gravitational potential energy from point A to point B is 3,920 joules. The mass of the drone is 2.5. Gravitational field strength is also given. It asks you to calculate the height above the ground when the motor was switched back on. So you're actually calculating this height. So it's whatever this height is, the red height is, take away 840, take away that height, gives you the blue height. So now let's do the question. Whenever you do these questions, it's best to practice doing the equations, the maths steps. So first extract the data. We've done it. This is GPE, this is mass, this is gravity. We're trying to find height. And the equation, the formula that we're going to choose is GPE is equal to mass times gravity times height. We substitute our numbers. 3920 is equal to 2.5 times by 9.8, which is gravity on Earth, by the way, times by height. And then we get the rearranged formula, 3920 divided by 2.5 times 9.8. Okay, when we do that, the height difference from A to B ends up being, or the change in height ends up being 160 meters. That is how far it drops. So, how far above the ground is it now? It's 840 meters minus 160 meters. is equal to 680 meters. That's your answer. Now I know I drew it a little bit off scale, but you understand it from the calculation. So, when the motor was switched off, the kinetic energy of the drone was 150 joules. Calculate the maximum possible speed of the drone when the motor was switched back on. Use the physics equation sheet. That's for the equation, and it give you your answer in kilometers per second. That's going to come in later. Firstly, the drone was moving at the top, and it had 150 joules of kinetic energy. However, after being dropped 160 meters, we know from the previous question, it has gained some kinetic energy. How much kinetic energy has it gained? The amount of kinetic energy gained has to be equal to the potential energy, gravitational potential energy lost. And it turns out 3,920 joules of gravitational potential energy was lost. Therefore, the new kinetic energy when the motor was switched back on is 150 plus 3,920 is 4,070 joules. We are asked to calculate the velocity or the speed of the drone. The equation that links kinetic energy with velocity is Ke is equal to 0.5 times by m times v squared. V we don't know, that's the velocity, but we do know m. That's the mass of the drone, and it's 2.5 kilograms. Next, you substitute the numbers into the equation. 4,070 is equal to 0.5 times by 2.5 times by v squared. A quick bit of rearranging gives you v squared is equal to 4070 divided by 0.5 times by 2.5. Now I'm going to do something really cheeky. Instead of writing this out, I'm just going to edit my PowerPoint. If I get rid of the squared on this side, I have to square root this side, and that answer ends up being 57.06 meters per second. However, meters per second is not the units that we are asked to calculate this in. We need to convert from meters per second to kilometers per second. To do that, you have to understand that 1,000 meters is equal to 1 kilometer. To go from meters to kilometers, you divide by 1,000. Dividing by 1,000 on this side also, you end up with 0.057 kilometers per second. So this question. Some people used to think that the radioactive substances had health benefits. In the 1920s, a water container called Revigator was sold. The walls of a Revigator contained radioactive isotopes. The Revigator was filled with water and left overnight. People then drank the water from the Revigator. The water was irradiated and contaminated by the radioactive isotopes in the walls of the Revigator. Explain how irradiating and contaminating the water affected the hazard caused by drinking the water. If it was irradiation, the radiation went into the water and didn't change the hazard. Why not? Because alpha particle goes in, changes nothing about the water, and it doesn't stay there. You could say that the radiation the radiation irradiated the water and maybe killed some of the bacteria in it. That would make the water better to drink, so you could say the hazard decreased. Two ways of going about that. Contaminating, on the other hand, there's only one answer for it. Contamination, the radioactive isotopes go into the water and you drink it. So it goes into you, therefore increases the hazard. Because that isotope, if it's inside you, it can be irradiating your cells, which could cause cancer. A scientist tested some water that had been left in the revigator. The water contained radon 222 and vanadium 52. Vanadium 52 decays by emitting beta particles. What is the correct nuclear equation for this process? Well, let's have a look where beta particles are remaining at the end of the decay. Here and here. So these are not it. Then vanadium 52, after it decays, creates a beta particle. Does it create Ti or Cr? Let's see. After the beta particle is released, you have to add up everything on the right hand side of the arrow, and it should be equal to the left hand side of the arrow. 52 plus 0 is 52. 22 minus 1 is actually 21, so it doesn't add up to 23. So it's not that. 52 plus 0 is 52. 24 plus minus 1, 24 minus 1 is 23. So that's the correct answer. 5.3. Now, in this table, it shows the radon half-life and the vanadium half-life. Scientists measured the radiation emitted by a sample of radon-222 and the radiation emitted by a sample of vanadium-222. They repeated the measurements 7.4 minutes later. Explain how the activity of radon-222 and vanadium-52 had changed after 7.4 minutes. Well, radon will almost have the same activity because 7.4 minutes is only a small fraction of its half-life, which is 3.8 days. We'll have almost the same radioactivity. Okay, why? Because 7.4 minutes is only a fraction of 3.8 days. Which means in 7.4 minutes, not many isotopes will have decayed. It takes 3.8 days for half of the isotopes in the radon-222 to decay. How about vanadium? It'll be different for vanadium because in 7.4 minutes, vanadium will have halved and halved again. I'm going to say will half, and halve again. Which means original activity divided by 4. Why is that? Because 2 half-lives have passed in 7.4 minutes. In other words, 3.7 times by 2 is 7.4 minutes. Scientists monitored the effects of drinking the water from a revigator. Their methods and results were checked by other scientists. What is the name given to the process where other scientists are checking work before it is published? Well, if you were doing some work and I asked you to pass it to the person next to you to check it, we call it peer marking. This is called peer review. Let's find questions about energy again. Energy can be stored using compressed air energy storage systems. When more electricity is generated than is needed, CAES systems uses the surplus electricity to compress air in a storage tank. When there is a greater demand for electricity, CAES systems releases the compressed air to generate electricity. So surplus electricity goes into the compressor, air is compressed, compressed air is stored, and then when you need energy, you let the compressed air out, and the generator spins and electricity is outputted. The CAES system has 2 processes: compressing air into the store, this process, and the second which is 0.72 in its efficiency, or 72% efficient, and this process which is 86% efficient, 0.86. Now, calculate the efficiency of CAE systems. Give your answer to two figs. You're asked to find out the efficiency of both of those put together. In other words, what is 72% of 86%? Or just times it together. And the answer happens to be 0.6192, which converts to 0.62. Doesn't have a units because it's efficiency. Next. So, when the air is coming out of the compressed tank, it hits a turbine and it rotates the turbine. When the particles of the air collide with the turbine, they transfer energy to the turbine. In warm weather, the temperature of the compressed air increases, which means the tank itself has a higher pressure. Explain how the motion of the particles in warm air causes the increased power transferred to the turbine. So in warm air, has a greater speed. Okay, so if that's the case, there's more particles coming out of the tank, so more collisions with turbine per second. And each collision has more energy to collide with, so collision transfers more energy. Because each collision has more force. Because it transfers more energy per second, we say it's got more power. More power because more energy transferred per second. Please ignore the handwriting. So, we have been asked to calculate the energy transfer to the compressed air in the storage tank when the temperature of the compressed air increases, and we've been given the volume, the density, and the specific heat capacity. First of all, the formula that we need is change in energy is equal to mass times specific heat capacity times change in temperature. We don't know the change in energy, that's what we've been asked to calculate. However, we do know some things. We know the change in temperature is from 12 degrees to 27 degrees, so it actually is 15 degrees Celsius. We know the specific heat capacity, which is right here, but we don't know the mass. There's a way to calculate the mass, and using volume and density, because density is equal to mass divided by volume. Therefore, 48 is equal to mass divided by 5 times 10 to the power of 5. Thankfully, there's no conversions needed just yet. Mass is then equal to 24 million, or 24,000,000. Then, using that mass, we substitute it into the equation and find change in energy is equal to 24 million times by 1100 times by 15 degrees, which gives you an answer of 396 billion, is it? With 9 zeros after it, which becomes 3.96 times 10 to the power of 11, which is what you write on the answer line. The UK government wants the amount of carbon dioxide released into the atmosphere to be reduced. Explain why the efficient energy storage is important in reducing the amount of carbon dioxide released when generating electricity. This is a tricky question. You need to understand what's going on here. It's asking, how do we reduce the amount of carbon dioxide that we use to make electricity? Well, what process releases carbon dioxide? Burning fossil fuels releases carbon dioxide. So the way to do that is use less fossil fuels. But if we use less fossil fuels, then we would have to use more renewable energy. but renewable energy is not as reliable as fossil fuels. So if we use less fossil fuels and we can't increase the amount of renewable energy, we have to make all of our energy usage more efficient. One way to do that is energy storage systems. And so that's working backwards. Working forwards, you have to say efficient energy storage wastes less energy. So less fossil fuels being burnt. So the number of renewables for generating electricity or renewable resources used for energy will have to increase. Energy stores, not stores, energy storage